Hello, Bristol. I think I can say that. We're sort of in Bristol virtually. And yeah, it's great to be here. I'm in London right now, actually. And this is what I'm going to be talking about. I'm going to be talking about teaching people how to build AI enhanced audio plugins. Okay, so my objectives with this talk are the following. So I want to describe the process of writing an audio dev book in case you're wondering where they come from. So I'm going to talk about that. And then I think I'm going to talk about well, I'm going to demo some of my software that's in the book, but also explain a bit about the sort of thinking behind it. Why have I made it like that? What kind of technologies is it aiming to teach, and so on. And then I'm going to present some examples of the actual research that I've done that backs up those examples you see in the book. So why have I ended up making that particular example? Okay, so first question is, who am I? And the answer is, I'm a kind of musician. So you can see a couple of nice pictures of me playing music there. And I've even got a video, actually. I think I've got a video of that top left one. I'm going to play that now. And here we go. Here's me playing with Alex McLean in our band called Canute. Okay, right, that's kind of fun. There's a lot of mad audio dev stuff going on there, which we don't really need to get into too much detail of, but I'm playing the drum kit. Drum kit's going into SuperCollider. SuperCollider's doing a statistical analysis of what I'm playing, and it's generating patterns of tidal cycles language, sending it over OSC to Alex. He's bringing it into his environment and then drinking beer, as far as I can tell in that picture. But anyway, that's all good. So that's the music, and then on the top right there's me and another line up with some more sort of traditional instruments, although the players aren't traditional. Like, you've got John Edwards on the bass, Finn Peters on the sax, who are fantastic players. And then the book at the top, which I'm going to talk about in a minute. And I'm also a researcher, and I also am the program director for the computer science degree at University of London. So I'm a professor at Goldsmiths Department of Computing, and we have this big international degree program that I run. And there I am teaching people how to do reinforcement learning. Okay, so I tried to sort of make sense of why the book is how it is. And this is part of my thought process. So I tried to make a timeline of all the things I've been doing over the years and all the technologies. So on the top is a bunch of releases that I've made, sort of albums and things. And then below that, I've got some of the technology I use. So going from my early days working with Amiga trackers, which I still love. I've actually just been working on a new tracker recently, and which you can get on my GitHub page. And then you've got VSTs. I started working in Cubase and didn't really like it, honestly. Great system, great piece of technology, but I like trackers. And then went through Pure Data to SuperCollider. And then at the bottom, sort of also working with different languages. So I started out writing some Java, which I'll talk about in a sec, and then did a lot of research work actually with SuperCollider, using it as a really powerful synth engine, as well as a sort of performance tool. And then eventually sort of got into C++ and JUCE and all those wonderful things you can do with that. And I'll talk more about why that happened here. So here's my sort of C++ journey. So I started, I guess, about 10 years ago. I've taught lots of languages, and I sort of learned C as an adult. My kind of the language I relearned, if you like, after doing a lot of programming as a kid and then stopping, was C. And then I went into Java and then C++. And the C++ was for teaching open frameworks, and just thought, yeah, this is a great language. I really like C++. I'm not sure I'm writing good C++ in this framework, because it allows me to write anything I want, really, because it's a sort of, a gateway drug from processing through to real C++, I suppose. And then in 2020, I developed a C++ course for the online degree. And I really wanted to teach object-oriented programming, and I really wanted to teach GUI programming. And so I was looking for a cross-platform GUI library. And as it turned out, JUCE just was a really good cross-platform GUI library. Of course, we know it better maybe as being an audio library, and of course, so the GUI app we ended up building was this kind of DJing app that you can see in the screenshot there. But still, it just in my spreadsheet where I was comparing and contrasting, JUCE just came out because it was just with really good build tools and all that stuff. So yes, that's what I used there. And then later, I started sort of mixing in some of the AI work with the JUCE environment and taught a course at Politecnico Milano. And I've taught this for a couple of years, and this allowed me to develop a lot more of the examples that you'll see in a minute in the book. Okay, so what about writing a book? Okay, so 2022, sort of decided to pitch in for a book. I've been meaning to kind of write a book proposal for a while for a textbook, and so this is how long it took. So 2022 mid, submit the proposal. It goes to reviewers. Reviewers said, yes, go ahead, publish. This is a good idea. And then I also had to do a sort of analysis of other books out there, the sort of competitor analysis, to prove that there was like a gap in the market for a book about kind of plugins and AI and audio. And then eventually signed a contract in September 22 saying, yes, of course I'll write 100,000 words in a year. No problem. I've got my sabbatical coming up, 4 months. I'll do some of it during that. And then, whoops, the sabbatical was actually in 2024. What a bit of a mistake. Never mind, carried on anyway. Lots of weekends spent writing lots of text. Eventually, only a month or two late, submitted the final text, 344 pages. And then, so basically in total, a year and a half after starting the writing, I had the hard copy in my hand. I've got one here. There you go. A year and a half later, you get one of these. So there you go. And so that's the book. Now, how did I go about designing it? So the book these are the sort of some of the constraints I was dealing with. So firstly, that I had a dog that kept trying to write code, which is a bit of an issue, but she's not great coder, but good barker. And then the idea was I wanted to aim the student at different groups, right? So students, of course, because I teach and I wanted to be able to use it for my teaching, but also for developers who wanted to get into machine learning and or audio programmers, and so different types of people using it. So I've kind of tried to pitch it at different people, cross-platform, flexible workflow. So I came up with the idea of using CMake, JUCE, libtorch, and C++. Obviously, those are my core technologies, and I'll talk more about that workflow in a couple of slides. And then I wanted to also teach a range of DSP and machine learning techniques. So I wanted to kind of pack everything I kind of thought was interesting and new about audio programming and machine learning. I wanted to pack it all into the book. And it started out probably more ambitious with like 6 big example programs that I'd make. But then it turns out that 3 was plenty to fill up the word count. And so I ended up with an amp simulator, a guitar amp, sort of nonlinear distortion thing, and then an improviser, a musical improviser, and I'm going to demo these in a minute, and also a thing called a meta controller. Right. So those are the examples, and you can see in the top picture, this is silly with the dog, and then the bottom picture, that is my sort of 3 computer setup that I used when I was writing the book with a Linux, Mac, and Windows computer there. Okay. So in terms of the build workflow, this is what I came up with. And this has come out from years of walking around labs, looking at people's screens, trying to solve their build problems and knowing what's good and what's not good, and what happens if the project builder for your framework breaks like the night before your new course starts, whatever, which has all happened to me. And so CMake seemed like a really sensible choice because it's really reliable, very widely supported tool which can generate projects for all kinds of IDEs. So it's got a flexibility, but also you can go right down to the command line and just do a build straight on the command line with very simple commands, and that is very good for debugging students' code, right? So if people have got issues, you can just say, okay, let's just forget the IDE because God knows what you've got configured there, and let's just drop down to CMake and just see if we can do a basic build on the command line and then build up from there, and solve the problem as you go. So it's a way of breaking problems down, build problems, which are a really big thing when you're teaching C++, is those really hairy error messages you can get, which really put people off. So yeah, that's one aspect of it. It also, of course, works for IDEs. So my preferred IDE ended up being VS Code because I was developing on those 3 machines you saw in that picture. I could move from machine to machine and have basically the same environment for my builds, and I found it was really great, and had excellent CMake plugin that worked really well, and you could do all the building, testing and running, debugging all in there. And so yeah, with a very simple interface. So I'm not very good at complicated interfaces. IDEs like Visual Studio Community and even Xcode really just overwhelm me. I can't really handle it. I just too many menus, too much stuff going on. So I really like VS Code because it reduces my cognitive load, and I think that's definitely probably true for students as well. Okay, so yeah, talking of cognitive load, the problem with teaching AI or what we maybe machine learning. Let's not argue about which is which for now, but teaching those technologies, and as well as teaching plugins and audio and DSP and how to use an IDE and what a project is, how to use some Python at the same time. And right, you've got a lot of layers going on there. And so my approach was to think of it as maybe making a few different types of cakes with those layers, right? So as you're working through the examples, maybe you start with a command line program that applies convolution to a bunch of numbers, and you can see, really just print them out and see exactly what's going on before you get into 44,100 numbers a second, right? Let's just process a few numbers and see what's going on, and then gradually build in the layers until eventually you've really got a clear idea of what that DSP loop is doing, or whatever, or what that machine learning process is doing. And then you build it up into a plugin and start bolting on those extra layers. And then before you know it, you're running it in your DAW, and you've got a great big birthday cake with candles on it. Okay, to really stretch that metaphor there. So what I want to do now is kind of go through some of the examples in the book and tell you what they were inspired by, and what I've done previously leading up to that. So this example is, I'm going to just play it, but it's basically a genetic algorithm powered modular synth programmer. So the idea is that you can explore the space of possible modular synth patches using an interactive genetic algorithm. Now, I first built this thing, I'll just say that before I play it. First built this in the year 2000 as my master's project, basically my master's final project. And I wrote it in Java using Phil Burke's amazing JSON library for Java, which allows you to do real-time audio in Java. And you can even make it work in an applet. So in someone's web browser, you were doing real-time audio, with lots of modules and really quite powerful stuff on, 25 years ago or whatever. So it's pretty cool back in the day. And then in 2015, because there was no way the original program was ever going to run again, I re-implemented the whole thing in Web Audio API. And that's what I'm going to show you here. And you can access this at that website I just showed as well, if you want to. So let's just watch this. This is me just clicking through. So each box is a sound, and I'm listening to the different sounds. I'm selecting one for breeding. Okay. And you've even got the purple ones that, so the purple ones are ones that other people have created and submitted to the server. And that feature is in the original 2000 version as well. It had some hacky Perl script on the back end that would write a text file out, and then you could bring them in. So so it had a networked element as well. So that's Evo Synth, and it's open source. You can get it, it's on GitHub and everything, or you can just run it. And the great thing is, in 2015, you can even run it on phones. So I had loads of people using it, and I did surveys with it and stuff like that. So that's the idea of exploring the space of sound synthesis possibilities, which I've always been super interested in. Here's another example of some work that was related to that. So this is the sort of sound matching idea, where in this one, I'm looking at how do you match a given sound with a given synthesizer. And the important feature of this I want to highlight is that we, at this point, I was really interested in doing it with VSTs. So not just making up my own synthesis engine that nobody's really interested in, or some crazy engine that nobody's ever going to use, but actually using ready-made black box VST plugins and trying to learn how to program those with different techniques. So we did it with genetic algorithms in 2007, 2017, did it with neural networks, and we're able to kind of automatically program the DX7 emulator in the paper for that one. But the problem with this is, unlike the previous one, it's quite difficult for people to access. So but it still had VSTs in it. So it's like you can kind of see where the angle I'm working towards. Okay, so this is the meta control. This is in the book. And what this does is it allows you to load, it's a plugin that hosts another plugin, which in and of itself is a cool example to learn about. But as well as that, you can then control the plugin that you're hosting using a neural network. So with this single dial that you can see on the GUI there, you can actually move through the space of all of the parameters of the synth in a sort of weird non-linear way. And you can even train it to move in particular ways that you want. So I'll just play some video of that. So that's a preset on the synth, or it's not actually, it's a random place in sound synthesis parameter space. So as I move the dial around, basically it jumps to like a completely different place in the parameter space. So with one dial, it's like a kind of super knob thing, like on the Yamaha things that you get, but instead of it just being a linear mapping, it's a kind of non-linear neural network mapping. And I should also say it's very much inspired by my synth parameter work, but also Rebecca Fiebrink's amazing sort of Wekinator research, which you should check out as well. Okay, next one. So the next demo is the Improviser. Okay, so where did that come from? So in this one, this is more from maybe from my music practice, I would say, as well as sort of research as well. But this is the idea that you make an autonomous improvising system. Let's just listen to an autonomous improviser. This is Martin Speak playing with an autonomous improvising system. Okay, that's cool. So, and that was a live broadcast on Radio 3, did it at the Welcome Collection. It looks like I'm like heavily interacting with it, but actually I pressed go and stepped back, and the AI just played this Access virus for me. Why not give it a nice voice, you know? And then also I've worked with Finn Peters a lot, and am at the moment, and you can see him in the top right there, where I was actually programming, live coding an algorithm that would improvise with what he was playing. So that's on YouTube, you can check out as well. And then when I moved into doing this in VST plugins, I was sort of collaborating with a group at Monash, and we worked together to develop it into a JUCE-based VST plugin. And the reason I've said spot the difference is the difference between the top and the bottom is, in the bottom one, I'm not there. I don't need to be there, because once you've got it as a VST plugin, people can just install it on their own machine and they can then use it, and it's super easy for them to figure out ways of doing it. So you've got Mark Dinverno in the bottom left there, who I've collaborated with for many years. He's doing a talk about ethics and AI and data, and what does it mean to interact with an AI and all that, and improvisation. And then on the bottom right, you've got Carlos Morigo, who I didn't know, but someone gave him the plugin, and we ended up really getting on very well and have a good chat. And he built a whole stage show around it, which I just didn't anticipate at all, where he's using it here. So here's Carlos Morigo. So what's the plugin doing? Well, he's got it controlling the lights. He's got it. He figured out he could use an audio to MIDI converter to get the violin sound into the plugin, so get it to play some synth sounds. So there's all kinds of layers he ended up using it for in a really creative way. So that was really inspired me to keep working on these plugins, and because it seemed to have a real impact on people, and when you make interesting sort of research tech available to them. Okay, so this is the second example then. So the Improviser, let's do a quick demo of this. Again, this is based around hierarchical Markov models, and it allows people to learn about sort of agency, the idea that the machine has agency, and thinking about ethical data sets, because it trains from scratch in real time. And yeah, so there we go. So let's play this one. This is the Improviser. And so I'm playing drums into it. So I play drum kit. So yeah, this is a sort of drum solo. Okay, so I'm playing some drums into the Improviser, and it's learning. It's now learnt from those drums. It's now playing back out what it's learnt. So this is statistically similar to what I just played in. And then in real time, I can just jump to another section of the drum solo and feed that in instead. So go, okay, how about this? Learn from this now. So great. So it's now learning from the more exciting bit of the drum solo. Sorry if that's really loud. There we go. So now it's improvising based on the two things that it's learned, a bit at the beginning and a bit later, and it will just keep going as long as you want. Okay, so that's the Improviser plugin. And so that's the second example in the book. Moving on quickly. So the next one, the final example, is an amp emulator. And this one is this kind of idea of neural audio processing, right? So we've done, I guess, symbolic audio, symbolic music control, and we've got sort of synthesizer parameter control. And this one is like, okay, let's just throw some audio through the neural network. And this is very much inspired by great work by Christian Steinmetz, then Damskag and Wright's sort of guitar amp emulators and the Guitar ML project, all that stuff. I thought that's really cool, but I want to make it teachable. So that's what I did with this example. And also I've got my own work working on, for example, this paper with Louis McCullum, which is sort of network bending, where we were getting DDSP, trained DSP networks, DDSP networks, and plugging oscillators and things into them in the middle of them and trying to freak them out. We called it network bending. So that's that one. And yeah, but I mean, also I end up with a sort of amp emulator rather than something more, crazy and out there, because there's a lot of guitar players out there. I wanted a more mainstream thing, and also it's a bit easier to lock it down and go, is this working correctly or not? So it's an opportunity to take more of a deeper dive into the idea of training and validation. And also I could look at performance evaluation. How fast does it run? Could you run it on, for example, an ARM chip? So there's a bunch of stuff. It teaches people how to test the speed of things and all kinds of. So I found it was a really deep dive I could take there. And this ended up being, I ended up writing a mini DSP course on this one to teach people about, furrow and ear and wave shaping and all that, and show why neural networks are different from that. So yeah, I got really into this one on the teaching front. And yeah, I guess we can hear a bit of this one. Now I'll apologize in advance because this one actually has me playing the bass guitar on it. So you won't be able to see it, but there we go. A bit of bass guitar. Okay, now we're going to switch the plugin on. It's pretty tough. So yeah, I mean, you can hear there's some weird stuff going, artifacts going on. That's all part of the fun, is learning about the training and what happens when little weird things happen on the signal and how do you fix that and all that. So that's the third example. And yeah, that was possibly the longest one. I'm kind of nearly out of time, so I'm just going to flick. I've got one or two more slides. So yeah, just to say, bringing up that theme of what happened, do you have greater impact with your work? Do more artists get hold of your work if you make plugins? And I've done a bit of work, this preliminary work. The stats are not that strong, but it looks like there's some interesting stuff going on. You can see that on the right-hand side there, plugins appear to get this much higher download rates than other types of projects on GitHub, for example. And it makes sense, right? Because if they get posted on Create Digital Music or Sonic State, whatever, then people are going to go and check them out. Whereas if a weird Python script goes on there, maybe it won't. So that's the thing. And so I think there's definitely a story to tell there about impact and how you can improve the reach of your and longevity of your work as well, which is a bit of an issue in the community of people working on this research side of things. Okay, so just to sort of get to the end here, here's the book. It's called Build AI Enhanced Audio Plugins with C++, released in 24. And this was my greatest moment, is that we found it in the London Foyles bookshop, and it was nestled a few steps away from Bjarne Straustrop's C++ book, which is a great honor. And then a few steps along, you can't quite see it, but there's the Kernighan and Ritchie C book, C programming language book there, which is pretty mind-blowing to end up on a shelf with those guys. I'm sure mine's a bit thinner, so I've got a bit of work to do on the width of the book, but that's okay. So there we go. So there we go. And so let's go back to the objectives. So I wanted to describe the process of writing an audio dev book and the thinking behind that and the sort of pedagogical approach and how I went about doing that, and then show you several examples of audio technology research that fed into the examples as well as the examples themselves. And I will say thanks very much for listening. There's that crazy diagram of my music technology life there for you to gaze at the end. And I'll say thanks very much.